Our topic for today will be simplifying radical expressions using properties of radicals. Radical expressions, most commonly mistaken as square roots, but in actuality is more than just two. It can be a cube root, a fourth root, and more. Radical expressions are defined by its radical symbol. The basic parts of radical expressions are the radical symbols, the index, and the radicand. Usually, there are also exponents inside the radicand, which are often simplified together. This radical expression is a cube root of 27. To start simplifying radical expressions, you must remember the properties of exponents. For example, quantity xy raised to a is equal to x raised to a y raised to a. And now, combine it together with the radical expression property. You'll get the product property of radicals and the quotient property of radicals. For example, two raised to 1/2 is equal to square root of 2. Another example is p raised to 4/2 times q raised to 1/2 is equal to p squared square root of q. Simplify all of the exponents first. 5/4 can also be 1 and 1/4. Therefore, c raised to 5/4 is equal to quantity c times quantity c raised to 1/4. Since all of them have the same denominator, all of them falls under the same radical symbol, except for the variable that has a whole numbered exponent. Therefore, c square root of a cube b c. After knowing these, there must be something that you must know before simplifying, and that is the perfect squares of numbers 1 to 20. Knowing these perfect square roots will help you simplify your radical expressions easier and faster. The same goes for cube roots. For example, square root of 36 is also equal to 6. And 36 is equivalent to 6 squared. Another example is cube root of 16 is equal to 2, and 16 is equivalent to 2 cubed. Variables can also be simplified as long as the exponents inside the radicand are divisible by the index. You can bring out the variable, and the remainder of the divisible exponent, if there is, should remain inside the radicand. For example, square root of x squared is also equal to x. Another example is cube root of n raised to 7 is equal to n squared cube root of n. Simplifying radical expressions that aren't perfect squares are a little tricky. To simplify the number, there should at least be one perfect square or cube factor, depending on the index. This is so that it can be brought outside of the radicand and break it down to a smaller amount. For example, square root of 75 is equal to square root of 25 times 3. And 25 is a perfect square, which is equal to 5 square root of 3. Another example is square root of 72 is equal to square root of 36 multiplied to 2. And it's equal to 6 square root of 2. Another important rule of radical expressions are that the denominator should not be a radical expression. How do you simplify this? First, separate them into two radical expressions. To take away the radical expression in the denominator, multiply the numerator and the denominator by the radical expression on the denominator. Therefore, quantity square root of x over square root of y multiplied to square root of y over square root of y is equal to square root of xy over square root of y squared, which is equal to square root of xy over y. One example is square root of 2 over 3. It is equal to square root of 2 over square root of 3 multiplied to square root of 3 over square root of 3 to get the final answer of square root of 6 over square root of 9, and it's equal to square root of 6 over 3.
Plus 1